Hi, hello everyone. Today we are going to see about let f be a field of all real numbers. So f be the field, it consists of the real numbers, and v be the set of the all sequence. So v be the set of the sequence, that means a1, a2 to an, where where a1 here ai, that means a1, a2, a3 belongs to field where equality, addition, and scalar multiplication are defined component. Prove V is the vector space over a field. So here F is a field and V is a sequences. So we have to prove that V is a vector space over a field. So let we consider that let W equal to we assume that W equal to A1 A2 to A1, that belongs to in capital V. Then for that v be the set of the sequence defined, v be the sequence defined as a1 to an for any two functions. So we take two functions because it has an addition and multiplications form, so we consider that two functions in the v. So it consists of two sequence, that means a1 to an and b1 to bn. So defined subtraction, so addition and scalar multiplication, we assume that if we add the two sequence means we get a1 plus a b1 plus a2 plus b2. That is, it is also a same, it is also a sequence. If we add the two different sequence means we get this sequence. If we multiply a term with a scalar value means we get the sequence. So where if we add the two sequence also we get the sequence, and if we multiply the scalar value with sequences we also get the sequences. So we have to prove first closure. So if we from this above term also, if we add the two sequences we get the sequence, so it is a closure. And associative is nothing but let f of a, f of b, f of c belongs to v, that means sequence of a, sequence of b, sequence of c belongs to v. So associative is f of a plus f of b plus f of c is f of a plus f of b whole bracket plus f of c. Likewise we have to prove. So we assume that f of a is a1 to an and b1 to bn. So this is given in the question, and what we do means if we add this means b1 plus c1, b2 plus c2. So if we add 3 means we get a1 plus b1 c1. So if we can multiply, we can change the bracket. So a1 plus b1 plus c1. Likewise also we do in the other sequences and other terms. So if we get means a1 plus b1 comma a2 plus b2 up to an plus bn plus c terms are separated. So we get the term as a1 plus a1 a2 plus b1 b2 plus c1 c2 term. It can be written as f of a plus f of b plus f of c. So existence of identity elements, in addition their identity element is 0. So if we add f of a plus f of 0 means we get f of a. So 0 terms plus f of a terms means we get 0 plus a1 plus 0 plus a2 to 0 plus an. So we get a1 plus a2 plus a2 an up to. So it is the same as it is what we add in the what we add the function with respect to 0 means we get the same functions. So f of 0 is the identity element of v. Then existence of inverse means here minus a is the inverse of the a. So minus f of a is the inverse element of the f of a. So it consists of minus symbol as the inverse element. So if we add means we get a1 a2 to an plus minus a1 comma minus a2 to minus an. So if we add means a1 minus a1 comma a2 minus a2 to an minus an. So it getting cancelled, so we get 0 as a identity element. So if we add the element add the given element and the inverse element, we get identity element. So if we add f of a with inverse element minus f of a means we get the identity element, that is f of 0. Next commutative rule is, it is very easy. F of a plus f of b, here a sequence, here b sequence, we can written as a equality addition, we get a plus b, a1 plus b1, a2 plus b2. So it can be changed as b1 plus a1, b2 plus a2. So it can be splitted into b1, b2, bn up to a1, a2 to an. So f of a plus f of b. So it can be written as f of b plus f of a. So it is the commutative, it satisfies the commutative rule. So to prove the vector space, we have to satisfy the another conditions. Take the alpha beta from values from the field, and f of a, f of b from the vector sequence. So alpha into f of a plus f of b means what we get means alpha into f of a plus alpha into f of b. That means alpha into f of a sequence, b sequence. If we add this term means a1 plus b1. If we multiply the alpha means we get alpha a1 plus alpha b1. So we can split these terms as if we take alpha as a common means alpha into a1 plus a2. So it can be written as alpha a1. And next terms, if we take alpha as a common means we get b1 comma b2 to bn. So it is written as alpha into f of b. So this is the solution. Then alpha plus b f of a means alpha plus beta is f of a is nothing but a1 to an. So alpha plus beta a1 comma alpha plus beta a2 to alpha plus beta an. So it can be changed as alpha a1 plus beta a1 comma alpha a2 beta a2 likewise. And we separate the terms as alpha a1 comma alpha a2 alpha an to beta a1 beta a2 beta an. So alpha into a f terms plus alpha into b f a terms. So how we split means take a plus b into f of a means alpha into f of a plus beta into f of b. Likewise we have to split. So as according to that we can change the values, and we get into the terms. Then alpha beta f of a means alpha into beta a1 a2 to an, beta into a1 beta a2 to beta an. So alpha into beta a1 alpha beta a2 alpha beta an. So if we take alpha beta as common means we get a1 comma a2 to an. So alpha beta into the sequence, given sequence, that is f of a. So 1 into f of a is, if we multiply 3 into 1 is 3, so 2 into 1 is 3. Likewise also 1 into f of a is f of a. Likewise also 1 into a f of a is the sequence of a. So a1 a2 to an. So a1 a2 a2 is the f of a. So it satisfies all the conditions. So it is a vector space over a field f. And what we do means, to prove w is a subspace of we consider that w equal to a1 to an. So we have to prove that w is the subspaces of why we take, since 0 comma 0 belongs to w means to prove it is a vector space, we have to choose the element is an abelian under the addition. So 0 already existed in a vector space. For subspace 0 also existed, so we consider here 0. So w1 equal to a1 a2 to an, w2 equal to b1 to bn can be the two elements of w, and w1 w2 belongs to w, ab belongs to r. So for that to prove subspace, this is the condition: one element from the field and one element from vectors. Then subspace plus one element from field and another element from subspace. So alpha into w1 plus alpha into beta into w2. Alpha into w1 is nothing but a1 to an, and beta into w2 is nothing but b1 to bn. So alpha a1 alpha a2 to alpha an plus beta b1 plus comma beta b2 beta bn. So alpha a1 plus beta, if we add means alpha a1 plus beta b1 to alpha an plus beta bn belongs to w. So it is the subspaces of w. So hope you all understand, and thank you.